The following video presentation is a demonstration of Jetstream products. This visual aid is not intended to serve as a complete training course. For complete safety, operations, and maintenance information, consult the Jetstream Pump Operation and Maintenance Manual. Do not use this equipment without proper supervision and training. Incorrect use of high-pressure Waterblast equipment may cause serious injury and/or death. All operating and maintenance personnel must be thoroughly trained in the safe operation, installation, and maintenance of this equipment prior to its use, and adequate supervision must be provided at all times. Before attempting to connect, operate, or repair this equipment, thoroughly read the Jetstream Pump Operation and Maintenance Manual and all safety warnings and pamphlets included with your unit. Please contact your Jetstream representative with any questions concerning safe and proper operating procedures prior to its use. The Safety Committee of the Waterjet Technology Association publishes a document entitled Recommended Practices for the Use of Manually Operated High-Pressure Water Jetting Equipment. For your own safety and the safety of those around you, it is recommended that you read these manuals and understand the practices they recommend before you operate the water blasting unit. The Jetstream Waterblast unit is designed to be a high-pressure water source for all types of water blasting operations. Jetstream makes waterblast units with multiple pressure ratings. 10,000 pounds per square inch, or PSI, 20,000 PSI, and 40,000 PSI are the most common. These are commonly known as 10K, 20K, and 40K units. Jetstream Waterblast units can be converted from one of these pressure ratings to another in a short period of time. A procedure to do so is described later in this program. No matter what the PSI rating, your unit is comprised of a high-pressure water pump commonly driven by a diesel engine. Power end. The pump is driven by the engine through the power takeoff, or PTO. The PTO is engaged by using a manual clutch lever that connects and disconnects the power to the pump. When the clutch is engaged, a belt drive system powers a crankshaft, similar to that of an automobile. The reciprocating action created by the power end enables the water pump to function, drawing the water in through the reserve tank and pushing it into the hose or conduit. Fluid end. The fluid end is the heart of every high-performance water blasting unit. It consists of a manifold, stuffing boxes, gland nuts, univalves, and plungers. The combined action of the fluid end assembly creates the high-pressure water discharge. Fluid ends are equipped with at least one safety device to prevent the pump from overpressurizing. The two most commonly used safety devices are the Rupture Disc assembly and a pressure relief valve. Waterblast units are equipped with a pressure gauge that monitors the system's back pressure. The 40,000 PSI unit is also equipped with a pressure switch to turn off the system if the inlet pressure falls below 25 psi. A minimum of 25 psi must be supplied to the pump at all times when running a 40,000 psi unit. The bypass valve helps control the amount of flow, or gallons per minute, going to the nozzle. It can also be used to help regulate the engine's RPM. When the bypass valve is being opened, the amount of water being directed to the nozzle is decreased and the excess water is redirected to the holding tank. As the valve is closed, the amount of volume at the nozzle is increased. This means the amount of water being bypassed to the holding tank is decreased. The water lube lines keep the packing cool to ensure longer packing life. The filtration system is also a critical component in a Waterblast system. It helps filter the dirt and debris that can cause serious damage to the fluid end components. The primary filter removes impurities in the water down to 10 to 25 microns. The micron number denotes the size of particles that will be allowed to pass through the system. The smaller the micron number, the cleaner the water. A secondary filter, called the polishing filter, can be used to improve the filtration level to 1 to 3 microns. They are commonly used in 40K systems. Daily inspection. The Jetstream Waterblast unit is simple to operate and maintain. But as with all heavy equipment, operators must be properly trained and the equipment must be inspected and serviced on a regular basis. Safety should be the first order of business on any Waterblast job. Failure to follow all safety precautions could result in serious injury or even death. Performing a daily check of the entire system before traveling to the job site will give you the opportunity to correct any minor problems before they become serious, and will allow you to make any necessary adjustments. In your walk-around, include a check of all chassis fluid levels. When necessary, lubricate the grease points on the PTO clutch assembly. See the operation manual for details. Lift the access cover and check the drive belt tension. It should match the specifications written on the diagram inside the access cover. A procedure to correct or adjust the tension is described later in this program. Next, check the tightness of the gland nuts. Loose gland nuts can be tightened with a pump wrench and a hammer. Gland nuts may have loosened during normal operation due to vibrations throughout the unit. Even a slightly loose gland nut will allow the packing to move back and forth and extrude outside the back of the gland nut. This causes excessive wear and tear and shortens packing life. Be sure the water lube lines are intact and securely in place. At the start of each day, inspect the filters before starting the pump. To check the primary filter, loosen the eye bolts on the lid of the filter housing. Open the lid and remove the sock filter. The filter should be clean and completely intact. When replacing the filter, be sure that the new filter is flush with the top of the filter housing and that the O-ring is set in the groove. If the O-ring is not properly set, it may become pinched and cause leaks. If you are operating a 40K Waterblast unit or you plan to convert your system to 40K during the workday, you should also check the secondary filter. Supply water is routed through this filter on 40K units to provide extra filtration down to 1 to 3 microns. The secondary filter is checked in a similar fashion. Loosen the lid attachments and swing the lid down. Remove the filter by removing the nut and washer that are holding the cartridge in place. Pull the filter cartridge out and inspect it for debris and torn spots, replacing it if necessary. Reinstall the cartridge and hand tighten the nut and washer to hold the cartridge in its place. Be sure to check that the O-ring is set in the groove before closing the lid. Check the gear oil level while the engine is running. The oil level should be about ½ an inch above the full line. When the pump is running, the level will go down to the full line. Use 80-90 gear oil to top off the unit. Open the air filter housing and check the main and secondary air filters. Look for buildup of dirt and debris that may affect performance and replace the filters if necessary. Return the filters to their housing and close the cover. Check the engine coolant level and add the proper coolant if necessary. The engine must be cold unless overflow bottles exist. See the operator's manual for information regarding the proper coolant for your unit. Also check the level in the engine fuel tank to be sure it is adequate for the job. Before moving the unit, double-check the air inflation condition of the tires as well as the lug nuts. Add air and tighten as necessary. Rupture discs. Rupture discs are designed to protect the unit from overpressurization. When an obstruction is present in the nozzle, or if the wrong size nozzle is used, rupture discs are forced to blow, bringing the system back down to a safe pressure. In most cases, there is only one rupture disc on the 10K and 20K units. It is located on the top of the fluid end. It can be identified by the red circular top with a blue sticker that indicates the disc burst pressure. There are two rupture discs on a 40K unit. One is rated at 1.2 times the working pressure, while the other is rated slightly higher at 1.4 times the working pressure. These rupture discs should be checked often and replaced immediately if they blow. To check and replace a rupture disc, unscrew the disc head with an adjustable wrench. Remove the disc and spacer and examine the disc. If it has been ruptured or is damaged, replace it with the properly rated burst disc provided by the manufacturer. Make sure the disc is installed with the tapered side downward and the dome side up. Replace the spacer with the tapered side down. Replace the cap and tighten it securely. Use only the properly rated rupture disc. Never use any other object to replace the rupture disc, as this may allow water pressure to build up and cause a dangerous or costly explosive failure elsewhere in the system. Note, if a rupture disc needs replacing, determine the reason that it failed and fix the problem before operating the unit again. Positioning and parking the unit. At the job site, park the unit on firm, level ground, out of the way of site traffic, and as close to the water supply source as practical. The unit can be leveled using the hand-operated jack stand. Once this is complete, the wheels need to be chalked before running the unit. Water blasting is a two-person operation. Cooperation is necessary for the safe completion of a water blasting job. Position the unit so the person handling the water blast gun will be in plain view of the person operating the pump. Water blasting often takes place in less than ideal conditions. Consider how the water blasting will affect the surrounding work area and traffic flow. Take the time to secure the area around the water blasting unit to keep traffic a safe distance away. Use appropriate safety markers, such as warning tape, pylons, and signs, to barricade the area around the blast site. Only authorized personnel with the proper personal protective equipment should be allowed in the restricted area. It is the responsibility of each individual to ensure the safety of everyone around them. Control panel. A control panel is located on the side of the engine compartment. It consists of an engine operation readout screen, a manual throttle control, which could be a rocker switch, a throttle knob, or both, and a key switch. Before starting the unit, operators should familiarize themselves with the controls. The key switch and engine start button, if applicable, will start the engine. To shut off the unit, turn the key switch to the off position. When in operation, the engine performance readout provides multiple measures of the system's performance. Various measures can be displayed on the screen using the menu buttons. The electronic readout system will give the operator a running description of the status of the engine and pump operation. Scrolling through the menu will enable the operator to display various functions of the unit, but engine RPM is always displayed on the screen. Either the throttle rocker switch or the throttle knob control the engine RPM during system operation. In addition, there are two switches nearby which enable or disable the automatic throttle control. Set these switches to the proper position for your unit. Attach and turn on the water supply. Check to make sure the system drain valves are closed. Look down inside the water reserve tank on the back of the unit. Check to see that the outlet strainer is clean and securely in place. Make sure the float balls located inside the tank are moving freely and that they will stop the flow of water when they are pulled upwards. When the tank fills up, these floats will rise and stop the flow of water until the reservoir begins to empty during operation. Attach the water supply hose at the job site to the inlet of the filter assembly on the back of the Waterblast unit and begin filling the reservoir with water. Look over the filters to make sure that no leaks are present. On 40K units, verify that the inlet pressure is above 25 psi on the secondary filter. Flushing the system. Once the water supply has been hooked up, the system needs to be purged. This will get rid of any dirt or debris that may have entered the system, which can restrict the flow and cause overpressurization. First, the manifold needs to be flushed. This should be done without any accessories hooked to the discharge port of the manifold. Turn the bypass valve all the way out, counterclockwise, to relieve system pressure. You will know it is all the way out when the O-ring is visible, flush with the face of the bypass valve body. Also make sure the throttle is set at idle. Set the auto throttle switch to manual and turn the throttle knob all the way in before turning the key. Disconnect the water supply hose and open the ball valves on the manifold. And turn on the water supply. Once the water tank is full, start the engine and engage the PTO. Water should be coming out of the open ports and valves. Allow this to continue for about a minute. Disengage the PTO and shut off the engine. Turn off the water supply. Reconnect the water hose and close the ball valves. It is now time to flush the entire system with the hoses and accessories in place, but without any nozzles or tips. Connect all of the supply hoses, control guns, and accessories to the discharge port of the manifold, just like the job will be set up. Attach the high-pressure hose to the discharge connection on the manifold. Use the safety lanyard to make sure it is secure. Once it is secure, tighten the safety lanyards. Attach the remaining lengths of high-pressure water hose that you will be using. If you're going to be using a one-type lance that doesn't have a trigger, install a foot pedal now. If you have a 40K unit that uses a tornado gun, install a bimode valve now. Locate every nozzle and/or tip in the system and remove them in order to flush the system without building pressure. Once it is certain there are no nozzles or tips in the line, then turn the water supply on. Treat this procedure in the same manner as you would an actual cleaning job, with an operator in place, prepared to blast. Start the unit and engage the PTO, making sure to follow the recommended startup procedures. At this time, water should be flowing out of the control gun or nozzle holder. Use the throttle to increase the engine RPMs to ensure a steady, unrestricted flow of water is exiting the system. Once the system has been flushed for a few minutes, disengage the PTO and shut off the engine. Make sure the control gun or nozzle is not placed in standing water or dirt because particles could make their way in. Turn the water supply off and the system is now completely purged. Bi-mode valve. On 40K units, high-pressure air must be supplied to the water-blasting tornado gun when the trigger is pulled. This enables the nozzle to spin rapidly. To control both the flow of air and water to this gun, a bi-mode valve assembly is connected to the system between the pump and the gun. It controls airflow to the water-blasting gun by means of a regulator mechanism to limit rotational speed. When the gun is not being triggered, the bi-mode valve cuts off both the air and water flow, serving as a dump valve to divert the water before it travels to the gun. Attach one end of the high-pressure water hose to the pump outlet. An anti-seize compound is recommended for application to the threads. Attach the other end of the hose to the inlet of the bi-mode valve. On the other side of the bi-mode valve, connect gun lines which include the high-pressure water line, the high-pressure air hose, and a smaller feedback line that runs from the gun back to the bi-mode valve. This is the signal line, designed to communicate back to the bi-mode valve when the trigger has been pulled. At the gun, leave the high-pressure water line disconnected, but connect both air lines to the gun so that it can trigger the bi-mode valve. A compressed air hose must be connected to the inlet on the bi-mode valve. A cartridge in the bi-mode valve allows the high-pressure water to go to the gun when the trigger is pulled, or to be diffused and discharged at low pressure when the trigger is not pulled. Adjusting the bi-mode valve. Adjust the bi-mode valve at this time. A regulator controls the amount of air pressure going through the system. The regulator can be monitored by the gauge. The regulator must be set above 60 psi, the minimum to push the cylinder down. 70 to 80 psi is the optimum level to operate the gun and bi-mode. The pressure can be adjusted by pulling up on the regulator and turning it either clockwise to increase the pressure or counterclockwise to decrease the pressure. After adjustments are made, the regulator should be locked in place by pushing the adjusting knob downward. Do not set the regulator above 125 psi. Regular air tool oil is used to supply oil to the air gun and all the moving parts inside the bimode valve. The oil level inside the lubricator should be checked and filled before starting the pump. To add oil, disconnect the air supply hose and then remove the screw on top of the lubricator. Add oil until the sight glass indicates a full level. And replace the screw. Reconnect the air supply hose. At this point, the 40K tornado gun will be connected to the bimode valve with the air lines only. The high-pressure water line will not be connected to the gun at this point. On 10 and 20K units, the high-pressure water line will also not be connected to the gun. Adjust the drip lubricator to 1 to 2 drops per second. Turn the knob clockwise for more oil or counterclockwise for less oil. Foot pedal. A foot pedal may be used to trigger the flow of high-pressure water when the operator cannot use his hands to trigger the mechanism. Attach the foot pedal in line with the high-pressure hoses leading to the high-pressure discharge end. When the pedal is pressed, the dump valve is closed and high-pressure water is allowed to reach the working end. Releasing the foot pedal opens the valve and diverts the flow of high-pressure water away from the nozzle. Water lube system. Check the water lube. You should notice a flow of water dribbling out the back of the gland nuts. During operation, this flow cools the packing inside the stuffing boxes. The water flow should be adjusted if there is no water coming out of the gland nuts, or if the water stream seems excessive. To change the amount of water going through, 3 needle valves may be adjusted. Turn them clockwise to reduce the amount of water and counterclockwise for more water. When the needle valve is open, and if water is still not coming out from the back of the gland nut, disengage the PTO, shut down the engine, pull the lube line off, and see if a sufficient amount of water is coming out. The line may have become clogged if the packing has deteriorated and extruded up into the line. If this is the case, the line may be pulled off and blown out with compressed air to free the clogged line. Check that the correct amount of water is coming out of the back once the pump is safely started again. When you have finished flushing the system and checking the lube system, disengage the PTO and turn off the engine. Safety gear. Safety should be the #1 concern when operating a Waterblast system. The operator of the blasting gun should always wear the complete outfit of proper safety gear before water blasting is begun. This is commonly referred to as personal protective equipment, or PPE. The minimal PPE includes but is not limited to the following: a hard hat with a safety shield, fogless safety glasses, ear protection, non-slip gloves, a rain suit, non-skid steel-toe rubber boots, and metatarsal shin and foot guards. Personal protective equipment must be used on Waterblast jobs. Such protective equipment is designed to help keep the operator as safe as possible under these conditions. Failure to wear this protective gear could increase the risk of serious injury or even death. Waterblasting. Make the final connection of the high-pressure water line to the Waterblast gun. Use an anti-seize compound for thread protection. On 40K units, install the burst shield. On other guns, install the safety shroud and whip check. Turn the bypass valve all the way out to relieve system pressure. Make sure the throttle is set at idle. The Waterblast gun operator should be visible to the pump operator and in position to blast when the engine is started. Start the engine. Engage the PTO. The blasting operator should trigger the gun so that pressure may be adjusted. Slowly turn the bypass valve in clockwise and increase the throttle until the desired pressure is achieved. The pressure gauge should be monitored at all times to ensure that proper pressure is maintained. Do not exceed the pressure rating of your unit. When the automatic throttle control is enabled, the system will react to the interruption of water blasting by lowering the engine RPM to idle, and then restoring the RPM to the level set by the operator when water blasting resumes. To shut down the unit, turn the bypass valve counterclockwise all the way out. And reduce the engine throttle. Disengage the PTO and turn off the engine. $10K to $40K conversion. The basic Jetstream Waterblast unit may be converted from a 10K or 20K unit to a 40K unit, depending on the requirements of the job application. To convert a unit from a 10 or 20K unit to a 40K unit, begin by locking out and tagging out the engine. Warning: to limit the risk of personal injury and/or damage to the manifold, the removal or installation of the manifold should not be attempted with fewer than 2 workers. To begin, ensure the unit is off, and then disconnect the automatic throttle sensor from the manifold. Disconnect the water lube lines from the top of the stuffing boxes. Remove all remaining hoses and water lines from the manifold. Loosen the cap screws holding the manifold in place. Replace the top 2 corner cap screws with threaded studs. Remove the cotter pin and trunnion rod from beneath the manifold. Slide the manifold off the studs. Remove the clamp assemblies that secure the plungers. Unscrew and remove the brass hose barbs from the stuffing boxes. Slide the 3 stuffing box assemblies out. Install the new 40K stuffing box assemblies into the unit. Apply Teflon tape to the threaded brass hose barbs and reinstall them on the top of the stuffing boxes. Reinstall and tighten the plunger clamp assemblies. Place the new manifold with the proper univalve cartridges installed into position. Be sure that the holes of the trunnion rod are aligned properly. Install the new manifold, sliding it forward until it is secure. Replace the trunnion rod beneath the manifold. Reinstall the 8 cap screws and tighten the bolts to the head. The 4 center bolts should be tightened first in an X pattern, followed by the 4 outer bolts, keeping the same X pattern. On the 40K unit, don't reconnect the water inlet hose to the manifold. Water must be filtered through the secondary filter when running the 40K unit and then fed into the manifold. So when you reconnect the water hoses, you must remove the elbow connector and route the water through the secondary filter, attaching the hose to the filter inlet behind the water reserve tank. In most cases, the water tank will not be used at 40K. When you have completed this connection, attach the outlet hose from the secondary filter to the manifold inlet. The water is now routed through the secondary filter. Reattach the water lube lines to the stuffing boxes and carefully close the cover, taking care not to pinch the lines. Reattach the remote throttle control. On the control panel, reposition the pressure switch to the 40K position. The basic steps of this procedure can be used to change back from a 40K unit to a 10K or 20K unit. When switching from a 40K unit to a 10 or 20K unit, remember that the water hose which leads into the secondary filter must be rerouted directly into the manifold. For complete instructions to convert any unit to another pressure rating, refer to the Jetstream Pump Operation and Maintenance Manual. Routine maintenance. Regular maintenance is required to extend the life of high-pressure water blasters and help protect operators from injury. Proper lockout and tag-out procedures should be implemented to prevent the use of the unit while it is waiting to be serviced. Belt drive tension. As part of your regular maintenance schedule, check the drive belt tension by raising the access door and measuring the belt deflection. Use a deflection gauge for this measurement. The readings should match the specifications written on the diagram inside the access cover. To take the reading, set the deflection O-ring on the belt tension gauge to 1/3 inch deflection. On the other end, position the O-ring at 0 pounds pressure. Push the gauge down on the midpoint of one of the center belts until the O-ring, showing 1/3 inch deflection, lines up with the top of the adjacent belt. Measure the resulting pressure. The specifications on this unit call for a pressure of 20 pounds. If it is not, you should adjust the tension of the belt by loosening the 4 power frame mounting nuts. And either turning the pump adjuster clockwise to move the power frame away from the engine, thereby tightening the belts, or turning the pump adjuster counterclockwise to move the power frame closer to the engine to loosen the belts. After making the necessary adjustments, place the tension gauge on the belt once again to make sure it reads 20 pounds at 1/3 inch deflection. Once the proper adjustments are made, retighten the 4 power frame mounting nuts and close the access door again before operating. Changing the power frame oil. The power frame oil should be changed at 500-hour intervals using 80-90 gear oil. To change the oil, ensure the unit is off. Remove the plug in the back of the power frame. Open the ball valve and drain. Replace the oil in the power frame by taking the breather off the top. Close the ball valve. Replace the plug to prevent inadvertent draining and put in 9 gallons of 80-90 gear oil. And put the breather back on. Start the unit back up and check that the oil level reads full while the unit is running. Packing inspection and replacement. In order to extend the life of the fluid end, the packing must be maintained and replaced as necessary. Warning signs that the packing may need to be replaced include, but are not limited to, low discharge pressure, pump pulsation, or a burst of water exiting the back whenever the plunger goes into the stuffing box. To replace the packing, lock out the engine to prevent starting. Use a pump wrench to loosen the gland nut and back it out nearly all the way. Using a 9/16 inch wrench and socket, loosen the plunger clamp from the crosshead stub. Next, take the clamp out and push the plunger into the stuffing box. Screw the gland nut out the rest of the way and wiggle the plunger inside the stuffing box. Pull everything out as one assembly. And remove the old packing. Inspect the plungers for any deep scratches. Inspect the bushing to be sure that everything is tight around the plunger. Insert the new packing with the larger side facing the gland nut and the tapered side away from the gland nut. Put the entire assembly back inside the stuffing box and rethread the gland nut a few turns. Push the plunger back into the crosshead stub. Once everything lines up, hand tighten the gland nuts and secure the plunger clamps. Reinstall the plunger clamp, making sure the clamp is going on evenly. With the pump wrench provided, finish tightening the gland nuts using a hammer. Examine and replace univalves. Univalves and face seals should also be examined if a low discharge pressure or pump cavitation is observed during operation. A good indication of cavitation is the jumping around of high-pressure hoses. Water coming out of the round weep holes may also indicate worn O-ring seals. To check the univalve and seals, you must swing down the manifold. First, ensure the unit is off. Disconnect the lube lines and remove the suction and discharge hoses. Swing down the manifold by using a pump wrench to loosen the screws. Leave one cap screw to support the manifold while removing the remainder. Remove the last cap screw and carefully lower the manifold, avoiding potential pinch points to expose 3 univalves and face seals. When water is seen coming out of the square weep holes, it is an indication that the face seals or O-rings are leaking. O-rings are commonly found on 10 and 20K units. Face seals are found on 40K units. To replace the face seals or O-rings, use a screwdriver to carefully pop out the face seal or O-ring. Inspect the seating surface and make sure it is free of debris. Press the new face seal or O-ring into place. If you've encountered a sudden loss of pressure or water coming out of the round weep holes in the top of the manifold, you must remove the univalve. To remove the univalve, place 2 flathead screwdrivers catching the machine groove just inside the valve and pop the univalve out. If water was observed coming out of the round weep holes, check the O-rings to see if they are worn. If low discharge is the problem, examine the discharge valve seat. Clean out the pocket with a clean towel, making sure the pocket is free of dirt. Press the refurbished univalve in with the palm of your hand until it is flush with the manifold. Swing the manifold back up and replace the cap screws. Be sure to hand tighten the cap screws in a crisscross pattern, then complete the tightening process in the same crisscross pattern. Reconnect the packing lube lines. And the suction and discharge lines. Bypass valve maintenance. The bypass valve controls all the discharge flow going out of the unit. Bypass valve cartridges may require attention if water is being bypassed or discharged when the knob is turned all the way in. To examine the bypass valve cartridge, stop the pump, shut off the engine, and ensure pressure in the system is released. Then remove the dump hose from the outlet adapter. Using an adjustable wrench, loosen the outlet adapter and remove the cartridge. Inspect the seating surface for debris. Clip on a new cartridge and replace it back into the bypass valve. Tighten securely. And reinstall the hose. Bimode valve maintenance. When both triggers are pulled on the gun and water is still discharging on the backside, the bimode valve cartridge must be replaced. The cartridge can be replaced after disconnecting the entire assembly. To replace the cartridge, unscrew the cartridge retainer. The cartridge is attached to the cartridge retainer, and it will come out as one assembly. Unclip the cartridge from the retainer and replace it with the new cartridge. Apply a thin layer of anti-seize compound. Reinstall the cartridge and tighten the retainer. Waterblast gun cartridge replacement. Waterblast guns also require maintenance to keep them running at peak performance. Many common problems such as stuttering and leakage can be traced to a worn-out cartridge. This is often caused by not fully depressing the trigger when using the gun rather than holding the trigger completely open or closed. Replacing the cartridge is simple and can restore the Waterblast gun to its original level of performance. To service a Waterblast gun, start by stopping the pump, shutting off the engine, and releasing all the pressure in the system. Then disconnect all the lines, and using an adjustable wrench, remove the cartridge from the top of the trigger housing by unscrewing the cartridge retainer. Unclip the old cartridge and install a new one. Use an anti-seize compound on the threads. And reinstall the cartridge, carefully tightening it with the wrench. The gun is now ready to go back into service. Replacing the cartridge on the foot pedal assembly. The foot pedal assembly can be reconditioned the same way, by replacing the cartridge when it has worn out. After stopping the pump, shutting off the engine and releasing all the pressure in the system, use an adjustable wrench to unscrew the water bypass outlet. The cartridge is clipped to this assembly. Replace the cartridge. Use an anti-seize compound on the threads. And reinstall the cartridge into the pedal assembly. Routine maintenance and simple repairs allow Jetstream high-pressure Waterblast units to provide continuous, exceptional performance. For more detailed operating and maintenance information, please refer to the Jetstream Pump Operation and Maintenance Manual provided with each unit. You can also contact your local Jetstream representative. Safety must not be taken casually with industrial equipment. Jetstream has produced a Waterblast safety video that covers many common safety problems and how to avoid them. If you have not already done so, it is recommended that following the viewing of this operations program, all operators of the Jetstream Waterblast equipment view the operations safety tape and read the Jetstream Waterblast safety manual. Failure to do so may endanger the safety of the operators and those nearby on the job site.